Okay, so today we're going to be doing surface area. Okay, first, surface area is just the amount of space on the outside of an object. Okay, so it's how much space is on the sides of it. Okay, an example would be like how much paint it takes to paint a cube, okay, or how much leather is on a basketball. It's the surface area, how much space is on the surface. Okay, so we have a figure here. And this prism has 6 faces. So the 6 faces, you have the front and the back, the bottom and the top, and the side on the left and the side on the right. So the outside is really just these 6 faces. So if I knew the space or the area of all the faces, then wouldn't that be the amount of surface area this figure has? So one way to do this is just to find the area of all the faces and add them together. Okay, now that will work on any figure as long as you can find the area of each face. Okay, a rectangular prism has 6 rectangles, so I can just define the area of the 6 rectangles and add them together and I get my surface area. Okay, other figures though aren't so easy, so we're going to explore some things and see if we can come up with some formulas. Okay, but you can always, if you forget how to use the formula or don't know what the formula is, you can always just come back to this. Okay, surface area is just the space on the outside of the figure, so find the area of all the faces and add them together. Alright, now first we need to make sure we understand what a net is. Okay, a net is basically an unfolded figure. So if you took that 3-dimensional figure and laid it out flat, what would it look like? Okay, what it does is a net allows you to see all the faces. Well, you can see how that would be helpful if we were looking for surface area. Since it's the area of all the faces, if we can see all the faces, then it's easier to find the area of each one. Okay, so here we have a rectangular prism. Right? And if I was to unfold this, I'm just going to kind of take the top part out and I'm going to unroll the box. And I'm going to get something that looks like this. Okay, see, this is the bottom of the box. These are the 4 sides of the box. And then this is the top. So if this folded up, then the top would fold right across the top. Okay, so this is what this looks like unfolded. You can see that I have 6 rectangles. The top and the bottom are the same size. The left and the right are the same size. The front and the back are the same size. Okay, so I could find the area of these 6 faces pretty easily from here. And then I could add them together and get the surface area. Okay, well what about a triangular prism? Well, the same thing. If I unfold the triangular prism, okay, I end up with this net. Okay, notice this one only has 3 rectangles because it only has 3 faces going around the sides. And then the 2 bases are on the side, the triangle. So if I folded the triangles up, and wrap these three sides around, I'd have my prism. Okay, so you can see I've got 3 rectangles and 2 triangles. Alright, and lastly we need to think about a cylinder. Okay, a cylinder, if you think about actually opening it up like a can and then cutting the edge and unrolling it, you would end up with a rectangle with 2 circles. Okay, because you'd wrap this part around into a circle, and then these circles would fit on the top and the bottom. Okay, so you get 1 big rectangle and 2 circles, and that's the net of a cylinder. Okay, so now we're going to use these nets to figure out our formulas. Alright, first we're going to look at our rectangular prism. Alright, so this is my net for my rectangular prism. Okay, well I'm looking for surface area, which I know is really just going to be adding all my areas together. Well, let's break it up into things we already have practiced doing before. Okay, these 2 pieces would be my 2 bases. So I already know how to find the area of the base. We did that when we did volume. So since this is a base and this is a base, then I just need to find the area of the base just like volume, except for this time I need to count both areas of both bases. So I have 2 bases this time. I also have this rectangle. 1 huge rectangle. Okay, now it's made up of these 4 individual rectangles, but couldn't I just find the area of this 1 rectangle? Wouldn't that be the same? That'd be faster, right? And this would be the area of the side. So if I could find the area of my 2 bases and the area of the side, then I would have my total surface area. So this is the area of my base, right? But since I have 2 of them, I need 2 times the area of the base. And then I need to add this to it. But what is this? Okay. This would be the height. So I know the height of that rectangle. But how would I know what the length of the rectangle is? Okay. Well, if you think about that length, all the way from here, all the way across over here, if I wrapped it back up into the prism, wouldn't that be the same as this rectangle? So it would be the same distance from here to here as it would to wrap around the base. Well, we know something that means find the distance around. Well, that's just perimeter. So the length of this middle rectangle will always just be the perimeter of the base. Okay? So if we know that this side is perimeter of the base and this side is height, then how would we find the area of this rectangle? Well, we would multiply the perimeter of the base times height. And that's all we do. We find the area of the base, multiply it by 2 because there's 2 bases. Then we find the perimeter of the base and multiply it by the height of the prism. And we add those 2 numbers together. That's it. And that is our formula for surface area of a rectangular prism. Don't forget that capital B stands for area of the base. Capital P stands for perimeter of the base. And H stands for height of the prism. So now when you have a rectangular prism, you can just use this formula. 2 times the area of the base plus the perimeter of the base times the height of the prism. And it will give you your surface area. Alright, now let's look at a triangular prism. Alright, here's the net for my triangular prism. Okay, I'm still wanting to find surface area. Well, isn't this a base? And this triangle over here is another base. And then this big rectangle is my other side. I know that this line is the height. This sounds familiar. And what do you think this line would be? Well, it would be the same as going around that triangle, which is the base. So again, that would be the perimeter of the base. That sounds familiar. So what do you think the formula for a triangular prism is? Okay, well, I need the area of both bases. So that would be 2 times the area of the base. And then I need the area of this rectangle, which would be this length times this length. Well, how far is this one? It's the same as the perimeter of the base, and this is the height of the prism. And I need to add the perimeter of the base times the height. So I get the exact same formula. Interesting. So this formula seems to work with all prisms, because you'll always have 2 bases on a prism, so you'll find the area of the base and double it, and the height of the prism and the perimeter of the base will always give you the large rectangle. So you'll always add the perimeter times the height. So this is your formula for all prisms, no matter what shape the base is. Okay, so what about cylinders? Before, we said cylinders were kind of like prisms. Well, are they still going to be like prisms? Okay, well, let's see. First, we've got our base on the top and our base on the bottom. Okay, and we've still got our height multiplied by whatever number this would be. Well, that length, wouldn't that be the same once it was wrapped back around into a cylinder? Wouldn't it be the same as the distance around the circle? So basically it's kind of like the perimeter of the circle, except for we don't call it perimeter for a circle, we call it circumference, right? But really it's the same thing. So will the same formula work for a cylinder that works for the prisms? Okay, yes, the exact same formula will work for a cylinder, except for you just have to remember that there's really not perimeter for a circle, it's called circumference. Okay, so we use the same formula for all cylinders and all prisms. Okay, it's just on cylinders we make sure that, yeah, we know we're not actually finding perimeter because it's a circle, but circumference is the same thing as perimeter for a circle. Now, how can this work the same on all of these and they're all different figures? Well, just like our volume formula, this formula takes into account the shape, because this B, area of the base, well, if the base is a rectangle, you're going to find the area of a rectangle. If the base is a triangle, well, that's telling you to find the area of a triangle. If the base is a circle, then that means find the area of the circle. Okay, so it doesn't really matter which type of prism you have or cylinder. This formula works for all of them. You'll always find the area of the base and double it, and you'll find the perimeter or circumference and multiply by height, and you'll add those two numbers together, because that will be adding the area of the side and the area of the two bases. Okay, so basically it's broken down into two pieces. The first piece finds the area of your bases. The second piece finds the area of the sides. And then you add them together. Okay, so now let's look at some examples. Alright, we have a rectangular prism, and I have the dimensions of 4 meters, 6 meters, and 7 meters. Okay, now as we know with the rectangular prism, you could really pick any sides to be the bases. So I'm going to use this side to be my base. Okay. So my formula is 2b plus ph. So all I'm looking for the area of my base, the perimeter of my base, and the height of my prism. So this is my base, so I can find the area of the base. The area of the base would be 4 meters by 6 meters, because it's a rectangle that's 4 by 6. So the area of my base is 24 meters squared. Okay, then I also need to find the perimeter of the base. Okay, this would be how far around that base. Okay, which would be 4, 6, 4, and 6. So the perimeter of the base would be 4 meters plus 6 meters plus 4 meters plus 6 meters, which would be a total of 20 meters. And then I also need the height of the prism. Okay, so I've got the three things I need: the area of the base, the perimeter of the base, and the height of the prism. So I can plug them in. Okay, 2 times 24 meters squared plus 20 meters times 7 meters. So then I can just multiply. I get 48 meters squared plus 140 meters squared. Okay, because I did 2 times 24 and got 48. And I did 20 times 7 and got 140. And also on this one it was meters times meters, so I got meters squared. So then I can add those together, and I get 188 meters squared. So the surface area of this prism is 188 meters squared. Alright? So, now let's look at an example of a triangular prism. Okay, when you're doing surface area, you have to have a lot more dimensions, because you need to be able to find the area of the base as well as the perimeter of the base. But I still use the same formula. Okay, so I have the area of my base. Well, this is a triangle. Okay, so the area of this base is going to be base times height divided by 2. So 5 meters times 4 meters divided by 2. So the area of my base is 10 meters squared. Okay, then I need to know the perimeter of my base. Okay, so the perimeter is 4 meters plus 4 meters plus 4 meters. So I get that the perimeter is 12 meters. And then my height is 10 meters. So I've got all three things I need. I've got the area of the base, the perimeter of the base, and the height of the prism. So I plug it in. 2 times 10 meters squared plus 12 meters times 10 meters. Okay, so now I'm going to multiply, and the 2 times 10 meters squared is 20 meters squared and 12 meters times 10 meters is 120 meters squared. And then I just add those two numbers together, and I get that the surface area is 140 meters squared. Okay, so the only difference here was when I found the area of the base, I had to use the triangle formula, because area of a triangle. And when I added the perimeter, there was only 3 sides to add, because it's a triangle. Other than that, it's exactly the same as the rectangular prism. Okay, so now let's look at the cylinder. Alright, so we've got our same formula. Okay, the radius is 3 meters, the height is 8 meters. Okay, so the area of my base, well, the area of my base is a circle, so pi times r squared. So pi times 3 squared, which is pi times 9. So I get that the area of the base is 28.26 meters squared. Okay, then perimeter, okay, is the distance around that circle. Well, remember, we don't really have perimeter, but we do have something just like perimeter. It's circumference, right? So it works the same way. So how do I find circumference of this circle? Well, circumference is pi times diameter. Well, if the radius is 3, well, then the diameter is 6. So pi times 6 is 18.84 meters. Okay, so the perimeter, or circumference, of the base is 18.84 meters. And then I also need to know the height, and the height is 8 meters. So I've got the area of the base, I've got the perimeter of the base, I've got the height of the cylinder. That's all I need. So I can plug it in. Okay, I get 2 times 28.26 meters squared plus 18.4 meters times 8 meters. Okay, and at this point all I have to do is multiply and add. Okay, so I get 56.52 meters squared plus 150.72 meters squared. And I add those together and I get that the surface area is 207.24 meters squared. Okay, again, this is exactly the same as the prisms. Only difference is when you find the area of the base, it's a circle, so I find the area of a circle. And when you find the perimeter, well, since there's not really a perimeter, we find circumference because it's the same thing. Okay, other than that, prisms and cylinders are exactly the same. Alright, so now let's see if you can do some. So you're going to find the surface area of the following figures. Okay, we have a rectangular prism that's 2 by 3 by 5. Okay, we have a triangular prism, and we have a cylinder. Okay, so you're going to find the surface area of the rectangular prism, the triangular prism, and the cylinder. And then we'll look at it together. Okay, so I'm going to start with the rectangular prism. Well, first, I know the formula is the same, so 2b plus pH. Okay, so I need the area of the base. Well, I have to pick which base because this is a rectangular prism. I could pick any side I want. Okay, so I'm going to choose this front piece to be the base. So that means my base would be a 2 by 3 rectangle, which is 6. So 2 times 6 plus the perimeter, the distance around, would be 2 plus 3 plus 2 plus 3. Because this side is 2, then 3, then 2, then 3. So that leaves my perimeter is 10, and then the height of the prism is that 5. So I've got 2 times 6 plus 10 times 5. So that gives me 12 plus 50. Alright, so when I add the 12 and the 50, I get 62 meters squared. Okay, so all I did was find the area of the base, the perimeter of the base, the height of the prism, and plug it in. And notice, I didn't actually use my units throughout the problem this time. I just put them on at the end because it's area, so I always know I end up with units squared. Okay, it doesn't matter if it's normal area or surface area. Okay, area is always area. It's always units squared because it's two-dimensional. It's just on the surface. Alright, then for the triangular prism, I have the same formula. Okay, so I got to find my base. Again, I'm going to use the front side. I could have used the back triangle, but since they're the same, it doesn't matter. Okay, so that triangle is a 3 by 2 triangle. So 2 times 3 divided by 2. So the area of the base is 3. Alright, then I need the perimeter, and it's a 3, 3, and a 3, so the perimeter is 9. And then this 6 is my height, so I get 2 times 3 plus 9 times 6. So that gives me 6 plus 54. So the surface area of this triangular prism is 60 meters squared. And then for my cylinder, okay, the surface area is still 2 times the area of the base plus the perimeter times the height, which is really circumference for a circle. Okay, so the area of my base is a circle, so pi times 4 squared, so that's pi times 16, so that gives me 50.14. So I can plug that in, 2 times 50.14, and then I need to find the perimeter, or the circumference. So that's pi times diameter. Well, if the radius is 4, the diameter is 8. So that gives me 25.12. And then the height of the cylinder is 10. So times 10. Okay, so now when I multiply, I get 100.28 plus 251.2. And that gives me a surface area of 351.48 meters squared. So we should be able to find surface area for any prisms or cylinders. But we need to be able to find one more thing, and that's lateral area. Now, if you already know surface area, then the lateral area is going to be easy because it's very similar. Lateral area is the space on the outside of the shape, but it's only on the sides of the figure. Okay, so in other words, it's the same thing as surface area, except for you don't count the bases. Okay, so it's like finding surface area, except for you don't add in the area of the bases. You just do the sides. So if you think about a cylinder, it's just around the side. It's not the top. It's not the bottom. So if you think about your formula for surface area, it's 2 times the base, because you're adding the area of the two bases, plus the perimeter times the height. Well, so if I don't want this to be surface area, if I want it to be lateral area, then I don't count the bases. Okay, so this is my formula for lateral area. It's the same thing as surface area, just without the bases. Okay, so we're going to go back and see if we can identify the lateral area, and I'm going to use this orange each time. We're going to identify the lateral area of all the figures we've done so far. Alright, so looking at this prism, we can see that since this is the lateral area, that our lateral area is here, so that's the 50, so the lateral area of this prism is 50 meters squared. So see, we actually already had it calculated. Okay, if you calculate the surface area, you already calculated the lateral area as well. The same thing for the triangular prism. The pH is your lateral area, so that's the 9 times 6, so the 54. The lateral area is 50. Excuse me, that should be 54 meters squared. Okay, and then the same thing for the cylinder. That's our lateral area, so it's already written down over here. So the lateral area is 251.2 meters squared. So see, lateral area is easy if you understand surface area. It's just the surface area without the bases. You can even see it here with this circle. This cylinder. Here's my lateral area. So the lateral area of this same cylinder is 150.72 meters squared. And for this triangular prism, the lateral area was 120 meters squared. And for this rectangular prism, the lateral area was 140 meters squared. Okay, so as you can see, this is our formula for surface area for all prisms and cylinders, and this is the formula for our lateral area for all prisms and cylinders. Okay, the surface area is the whole thing, and the lateral area is just the rectangle in the middle without the bases. So now we should be able to calculate surface area and lateral area for all prisms and cylinders.